Still doing the IGCSE from June 2019, and this one is about inversely proportional numbers, or formulae. So when you have inversely proportional, we'll say y little fish 1 over x squared, in this case the square of x, which means y equals k over the square of x squared. Now, whichever numbers you put in, you're going to find out what k is. So I'm going to take the easiest numbers. I think these are the easiest numbers. So y equals k, or rather 9 equals, let's go for that, 9 equals k over 2 squared, so that means 9 equals k over 4. So we'll times both sides by 4, and we get 36 equals k. So then we write it out again, and we say y equals 36 over x squared, which kind of interferes with the 3. Now, given that x is greater than 0, so that means we're going to get more than one answer perhaps, find the value of x when y is 144. So we say 144 equals 36 over x squared. Now, you can just swap 144 and x squared, but I'll quickly show you why. 144 times x squared equals 36. X squared, therefore, equals 36 over 144. And both of those are divisible by 12, so that means x squared equals 3 over 12. Oh, x squared equals a quarter. Now we have to square root that. So if we square root both sides, we get x equals plus or minus a half. But we know it's only going to be greater than 0, so x equals a half. And that's your answer. Right, next question. This is quite a weird looking question. The table gives numbers about the first 6 terms of a sequence of numbers. Prove, it's a proof algebraically that the sum of 2 consecutive numbers of the sequence is always a square number. Okay, so I'm just going to write this out in a way that I think makes sense. It's all over 2, so I'm not going to think about put 2 in afterwards, but we can put half. So so let's make 1n, n times n plus 1. I should write that in a more algebraic way, but I'm not. Then we add half. It's 2 times 3, so that would be n plus 1 times, I realise I should put in brackets, n plus 2. Right, now let's do this. So it's half n squared plus n plus half, and that would be n squared plus 1n plus 2n, so 3n. That's that going that way and that way. There we go. And then plus 3. No, plus 2. Moron. Don't call yourself a moron. So that we can add them all together. So we can take a half out the front, do this, and it's 2n squared plus 4n plus 2. Now we can halve all of those, so we get n squared plus 2n plus 1. And if we look at that, it means that something has to times to 1 and add to 2, so that would be 1 and 1. So that means n plus 1 times n plus 1, and n plus 1 times n plus 1 equals n plus 1 squared, which means no matter what number you put into there, so 3, 24, 1,426 plus 1, it would always be a square number because you then square the answer. And that is the answer. So your proof is that we did all the left-hand side and we got the right-hand side, and the right-hand side is a square. There you go. So that was a proof. The functions for f and g are defined as f of x equals x over 4x minus 3, and g of x equals x minus 5. State which value of x must be excluded from any domain of the function f. Oh, right, okay. So what we can't have, we can't have a 0 at the bottom because it just means it doesn't work. It doesn't make it infinite, it just makes it non-existent. So if we go 4x minus 3 equals 0, what do we have to put in to get 0? So we add 3 to both sides, so x equals 3/4. So if x equals 3/4, it doesn't work. Find f, g, x and simplify your answer. So that means we take the thing that's closest to the x, which is the g of x, this bit, and then we put that into wherever it's x, which is 2 places. So we know that 4x minus 5 minus 3 equals, and x equals x minus 5. And we have to do that in quite a lot of places, so it's reasonable to understand that, or get to understand it. So on top we've got x plus 5, and that equals x minus 5, or rather we have x minus 5, 4x minus 20, and then minus 3, so that's x minus 5 over, I think that's 4x minus 23. Nice. Well, I'm not sure I mean that, to be honest. I don't really like that answer. I think it's basically having prime numbers and things doesn't make me happy. Express the inverse function f to the minus 1 in the form f to the minus 1 x. So this one's going to be a bit tricky. So to do the inverse function, we make f of x y, and then we have to find, we've won, let's just do this, so it's x over 4x minus 3. So we win when we get x equals something. We'll find out what. So let's times out by 4x minus 3. So we get y equals 4x minus 3 equals x. Now, we haven't won yet because we've still got an x on the other side, and we need to get all the x's on one side. So let's times out 4x times y, 4xy minus 3y equals x. I think we're going to take, let's add the 3y to both sides. That's 4xy. Good Lord, McCorkindale. x plus 3y. And then let's take the x off that side. So 4xy minus x equals 3y. And then let's remove the x from this. So it's x, it's called factorising. So x 4y minus 1 equals 3y, and then x equals 3y 4y minus 1. So now we've won because we don't have any x's on this side, on the right hand side. So now we can say f to the minus 1 of x equals 3x over 4x minus 1. And that is your answer. And actually, weirdly, you're just kind of swapping the bits at the top and the bottom around. Right, I'm going to try and do this before I run out of time. Part of the curve with the equation y equals hx. Oh, this is the same question that's shown on the grid. Okay, find the estimate for the gradient of the curve at the point where x equals minus 0.5. Okay, so I'm going to have to use this, and x equals 0.5 here. So what we want is to draw a line through there. What's that like? I think let's just make sure it's actually on the point where it's there. I think that's right. Let's try it. Okay. Now, I don't really ever trust myself with these, but I think they're fairly lenient. So that means that goes down to, and that goes along 3.2. No, it doesn't. I haven't looked at all at what it says. So this says 10, and this says that's minus 1, that's 0, that's 1.5, so that's like minus 1, that's 1.6. So that means it's 10 over 1.6, which I actually have to have a calculator for. That's 6.25. You see, I would not have got that by looking at it. It's not a very eyeball-y thing, is it? There you go. And that is the end of question 18.